day, out of which only 400 liters is being charged. Other 400 million liters per day is lost in the form of leaks and pilferage. From our survey, we found that most of it goes into leakage, and since the pipelines are underground, there is no way of telling where the leakages are. Endobot is a robotic device which can travel inside underground pipelines to identify various types of defects.
Other than water pipelines, Solinas has also developed similar devices that can be used in oil and gas pipelines. It is the recent access to open source electronics that has made such robotic automations possible at an affordable price.
The Institute of Eminence scheme has been launched by the Government of India to empower higher educational institutions and help them become world-class teaching and research institutions. IIT Madras is proud to have been selected as one of the select institutes of excellence. As part of our commitment to the cause of fostering world-class research, IIT Madras has set up a number of research initiatives in diverse fields of contemporary relevance. Many of these initiatives will go on to become centers of excellence within the IIT Madras system. A total of 68 research initiatives belonging to 21 identified technology clusters are presently underway. As part of these initiatives, it is proposed to host a series of webinars from each cluster to showcase the innovative research being generated to various stakeholders like researchers, industrialists, and policymakers. These webinars will give an opportunity to engage in conversation with eminent faculty from IIT Madras and other international researchers, and also to find more collaboration in those research areas. So why wait? Click the link below to be a part of this.
Coupled with slow moving traffic, heavily overloaded truck, in the 12 months period,
Hello and good day to everyone. Thank you for joining us today. On behalf of the Office of Global Engagement, it is my pleasure to welcome you to the 62nd webinar from the IRIS webinar series. My name is Richu George and I'm a part of the Office of Global Engagement at IIT Madras. The Institute of Eminence scheme was launched by the Government of India to empower higher educational institutions and help them become world-class teaching and research centers. IIT Madras is proud to have been selected as one such Institute of Eminence. A total of 68 research initiatives belonging to 21 identified technology clusters are presently underway at IIT Madras. And as a part of these initiatives, the IRIS webinar series aims to showcase the innovative research being generated to various stakeholders like the students, researchers, industrialists, and policymakers. And from the Autonomous Systems Technology Cluster, the research initiative presenting today is titled Marine Autonomous Systems, led by Dr. Abhilash Somayajula. Most of the marine accidents that occur every year can be attributed to human error. This research initiative aims to investigate the challenges associated with the development of autonomous ships that can lead to safer navigation. To introduce Dr. Abhilash, he is an assistant professor at the Department of Ocean Engineering at IIT Madras. He obtained his bachelor's and master's degree from IIT Kharagpur in 2011 and obtained his PhD in ocean engineering from Texas A&M University in 2017. From 2017 to 2019, he was a research assistant professor at the Department of Ocean Engineering of Texas A&M University. Since 2019, he has been with the Department of Ocean Engineering at IIT Madras. His research interests include hydrodynamics, marine autonomous vehicles, system identification for improvement of marine system modeling, and AI-based control of marine vehicles. Thank you for being with us today, Professor Abhilash. Now it is my pleasure to introduce the moderator for the webinar today, Dr. Antonio Pascoal. Dr. Pascoal is a professor of control and robotics at IST Portugal. He obtained his bachelor's degree from IST Portugal in 1974, a MS in electrical engineering from University of Minnesota in 1983, and a PhD degree in control science from University of Minnesota in 1987. Since 1998, he has been with the Department of Electrical Engineering of IST. He has coordinated and participated in many international projects with institutions in Europe, the United States, India, and Korea. His research interests include dynamical systems theory, marine robotics, navigation, guidance and control of autonomous vehicles, and networked control and estimation with applications to air and underwater robots. Thank you for joining us today, Dr. Bhaskar. We're very excited that you could be a part of this session. We also have Professor Suresh Rajendran and Professor Vijay Kumar R on the panel with us today. A very warm welcome to you too. And before we start, a note to the participants, please use the Q&A to enter your questions and upvote questions that interest you so that the moderator can prioritize them later. Over to you, Professor Abhilash.
Thank you very much. All right. Is my screen visible?
Yeah, we can see you.
And my audio is fine?
Yes, all good.
All right. All right. Thank you very much. Welcome to this webinar on Center for Marine Autonomous Systems, which is being organized under the IIT Madras Initiative for Research Initiative Spotlight, or IRIS webinar series. So my name is Dr. Abhilash Somayajula, and I'm a professor assistant professor in the Department of Ocean Engineering at IIT Madras. In this talk, I'm hoping that after the presentation of this webinar, we can leave the audience with three things. Why we need a Center for Marine Autonomous Systems, what are its goals, and how does the center propose to achieve these? That would be my target for the audience here today. So please sit back and enjoy. So here is an outline of what we'll be covering. We'll talk a little bit about the motivation behind developing autonomous ships, challenges associated with it. Then we will introduce our team members of collaborators. And then we'll talk a little bit about the goals of the center, the current activities, and finally we'll close out by talking about how one can get involved in this center. So what you see here are two graphs, and the one on the left shows you a histogram plot of the marine casualties and incidents that occur in 1 year, over 1 year's period of time. And these are categorized into different components based on what is the cause for these incidents. And you can see that they range all the way from environmental effects to equipment failure to human erroneous action and other vessel or other agents' mistakes. But one thing jumps straight out of the chart here, which is the human erroneous action. And you can see that almost 60% could be attributed to it. And that is the main motivation behind autonomous ships. But then one can argue that whether actually all these erroneous actions are happening on board a vessel. And that's where we come to the graph on the right, where you see that the shipboard operations contribute more than the shore-based operations. So operations which are performed on the ship these generally are leading to more marine casualties or incidents as compared to the number of incidents which are occurring on the shore and resulting in an incident. So the idea behind the autonomous ship development is to eliminate the crew from the ship and hopefully see a reduced human risk or human error. So if we reduce the human element, take it out, then hopefully we will have a reduction in the number of incidents or the accidents which we generally see in the maritime sector. So the primary idea behind it is to automate all the mundane operations which the crew performs regularly on board a vessel. But then at the same time, we do want to maintain a remote operation of the vehicle for critical situations. So where situations warrant that immediate action be taken over, then the human element should still be in the loop when we are dealing with these autonomous vessels. Now, when we are looking at autonomous vessels, we can get a little more creative and we can start looking at better designs than our conventional ships. So if you look at a picture, the two pictures shown here, you can see that the picture on the right shows the container ship as is seen in the current times. And the one on the left shows you a concept ship which has been proposed by Rolls-Royce. And you can immediately see that there are certain differences. There is no bridge on the ship on the left. And similarly, in the front, there seems to be a different shape altogether. And let's try to talk a little bit about why that is the case so as to motivate this reason for the autonomous ships a little bit more. On a traditional ship, you require the bridge because the persons or the crew manning the ship are housed in the bridge and are able to control the ship from the bridge. Also, a line of sight needs to be maintained. So therefore, you should not have obstructions from the bridge to the outer sea. Similarly, you want the crew to be able to sense their environment around them. So the structure of the hull is built in such a manner that this can be achieved. But if we remove the crew altogether from the ship, we can go for more creative designs. First, we need not have the accommodation deck. And that space, you don't have to have galleys, you don't have to have accommodation. All of that space can now be reallocated to carry more cargo. Similarly, since there are no crew, you don't have to pay any crew salaries. And you can also get a little more creative with the design of the ship, particularly to make sure that it is more streamlined so that the wind resistance is a little low. And that will have significant effects on the energy consumption of the vessel. So these are the primary factors which generally motivate the autonomous ships. But here it is important to understand that suppose if we have a vessel which is a really large vessel, then the crew operation costs only account for a minute drop in the bucket as compared to the total operation cost of the vessel. In such a scenario, the additional technology that is needed to be installed on the vessel to make it autonomous may not be as cost effective. So when we talk about autonomous ships, unfortunately, the economies of scale may not always apply. And sometimes we might be looking more towards mid-sized ships for autonomous operations. So that is where really the advantage or the break-even lies, where the technology which we need to improve upon in bringing to the vessel is has a cost benefit by taking the crew out of the vessel. An often line of thought which comes across is we have made leaps and bounds of progress in autonomous cars. Why can't we simply port them to autonomous ships? And there are slight differences here, and I'll try to illustrate why we are having a difference between autonomous cars and ships. Cars are mechanical systems where you typically have a mechanical connection between your steering to the wheels. So when you turn a steering wheel, your car turns almost instantaneously. Whereas ships are slightly different. The moment you want to turn a ship and you apply a rudder, it does not turn instantly. It takes a while for the fluid forces to develop, and then the ship starts to execute the turn. So they are much more sluggish in nature due to the inertia of these vessels. They're much more sluggish in nature, and therefore you have to take the preventive action much ahead on time rather than immediately. The other aspect which differentiates autonomous ships from cars is the idea that in autonomous cars, you want to do away with the remote operation as much as possible. You want to make the car completely autonomous, devoid of the human, but that's not the case with ships, or at least possibly when we go into autonomous ship sector, that will not be the case for a few years to come. The reason is we have a significant amount of cargo being carried along with the ships, and it is unlikely that an owner or an operator would be comfortable to operate these vessels without having any monitoring system in place. So for most foreseeable future, we will have a human in the loop when we are dealing with autonomous ships. So we may be looking at more what we call as unmanned ships. And for this, the human's presence will be crucial, especially in the critical scenarios. It is important to understand that currently there are no fully autonomous ships operating in the international waters. Although some have been planned for 2021, but still as of now, there are no fully autonomous ships operating in the international waters. One might ask, is this due to the technology not being there? But the truth is not that. The reality is there are other factors which make this development of autonomous ships more complex. We do not have the regulations in place. We don't have a safety assessment criteria which is fully set up, and we are still concerned with security and cost effectiveness. And these are some of the factors which kind of are the reason why we are not seeing fully autonomous vessels in operation today. So let's talk a little bit about each of these to get to the context of this. So just like cars have to follow certain rules on the road, so do ships have to follow certain rules when they are operating in the navigational channels. And these rules are known as COLREGs or collision regulations, were set up way in the 1970s. And they require some modification in order to accommodate the newer breed of autonomous vessels. We still are not at a level where these collision regulations take into account simultaneous operation between the manned and the unmanned vessels. Also, safety is a major criterion. When signing off on a ship design, a classification society has to have certain concrete metrics. If we don't have a particular setup metric which determines how safe an autonomous vessel is, it is difficult for classification societies to sign off on them and bring them into the operation. So we need standard metrics of safety to be incorporated or to be developed before autonomous vessels can see international waters. Similarly, when accidents happen, who is liable when an autonomous ship is involved? These are questions which are still unanswered as of now. Similarly, when vessels cross into different state lines, who gets to control the operation in the event of a critical scenario? Is it the flag state which is in whose operation the ship is, or is it the owner who has to take control of the vessel? So some guidelines have to be fixed up before we can bring these vessels to a reality. Security and cost effectiveness. So let's talk about the idea that when we take away the crew, we need different amount of sensors to sense the environment around the ship so that the ship can perceive its environment and accordingly make the autonomous decisions. And also, since we mentioned that a human in the loop is important, it is important that we maintain reliable communication of this collected information back to the shore control. So you need high-speed data transfers without any connection breaks, or where you are able to reduce these connection breaks. Similarly, cybersecurity is a threat that has to be dealt with effectively, especially with respect to spoofing or with respect to hacking. And finally, cost effectiveness is the bottom line for the maritime industry. The technology cost that is required to make a vessel autonomous and that needs to be installed on the vessel must be offset by the revenues it will earn by taking the crew out of the equation. And as long as this happens, then we can see the autonomous vessels come into existence. So as you can see, it's not the technology so much, but other constraints, especially metrics to determine whether a vessel is safe or not, that determine why we are not having the autonomous vessels in operation today. Some of the other technological needs are communication, sensing capabilities, and data processing. This is a big area where we are having a lot of work going on, where this entire information that is collected from the sensors needs to be processed in almost real time so as to make sense of it and take an action accordingly. And that requires newer algorithms, newer software structures to be in place, and that is where one of the technological challenges still persists today. And finally, reliability and safety. We have to ensure that these vessels can operate safely in the environments without causing more incidents than what we saw with manned vessels. And that is a big question mark as to how do we quantify it. And in order to quantify it, we need a lot of testing. We need a lot of way to go forward and perform simulated studies, look at how well these scale to the experiments, gain experience from them, and then accordingly tune our algorithms to make these systems more and more robust. So as you can see, there is a multiple of disciplines that are required which come into this gamut of autonomous ships area. So we have the hydrodynamics, where we understand the dynamics of the vessel. We have control systems which determine how can we control the vessel effectively. Then we have newer methodologies for path planning or for control using artificial intelligence, robotics, and softwares or algorithms for the development of autonomy. And you can see that no one group can typically claim expertise over all the 5 areas or 5 or 6 areas as needed. So it is the best way to go forward is to go through collaborations. And this is where our collaborative team comes into the picture. So our team is composed of 3 professors from IIT Madras. So we have the co-PIs as Dr. Suresh Rajendran and Dr. R. Vijay Kumar. And we have a set of experts from other universities who will help us fill in the gaps in order to achieve this collaborative approach. So we have Dr. Shrikant Saripalli from Texas A&M University, Dr. Sanjay Sharma from University of Plymouth, Dr. Prasad Pereira from UIT Norway, Dr. Antonio Pascoal from IST Portugal, and Dr. Mike Benjamin from MIT. So with this collaborative group, we hope to achieve or solve some of the challenges associated with the determining of the safety for autonomous vessels and how we can cooperatively control these vessels, how they can work together to make the system much more robust and safe. So if we look at what are the goals of the center, within the first phase, we have a goal of building multiple vessels, especially in a scaled vessels. So since we are interested in scaling this up to the real life where we have big ships, we need to be able to perform model experiments also on a similar shapes. Unfortunately, many of the autonomous platforms which are available commercially off the shelf today do not cater to this need. They are not exact hull forms of real ships, but rather they have a different form, whether it be a planing craft or whether it be a completely flat-bottomed catamaran surfaces. So therefore, with that objective, one of the goals of the center is to build a fleet of vehicles which are scaled models of ships that can act as a test bed for our center to investigate these problems. And the next idea is to equip them with the guidance, navigation, and control stacks so that each of the vehicles is self-sufficient and can act as a test bed provided it is given a mission. So this can be achieved using both traditional methods as well as AI-based methods, and we are going to be looking at both of these processes. Although in the traditional methods are well established, the artificial intelligence-based path plannings or control are some new things or newer areas which are making rapid progress in these in the areas of the autonomous vessels. We will also be looking at software frameworks. So we'll be developing frameworks in robot operating system, and we'll also be investigating another framework called as Moose IVP. Both of these are open source architectures which will allow us to build further on existing tools and tune them according to our requirements. Moose IVP is a program which has originated from MIT, and Dr. Mike Benjamin, one of our collaborators from MIT, is in charge of this program. In phase 2, we are planning to be a little bit more ambitious, where we want to look at a heterogeneous fleet of vehicles, where these vehicles are all equipped with different types of sensors, whether they be in terms of a LiDAR and a GPS or a IMU or some combination of these sensors. And we are trying to look at a control objective or a mission objective using a heterogeneous fleet of vehicles. And this is where really cooperative control comes into the picture, where we are trying to look at how can the vehicles communicate information between each other using the sensors which they have and achieve the mission objective, which could be to avoid collisions or could be to operate inside a restricted waterway. And how do we go about, what are the metrics for going about this, and what are the strategies for going about this? Some of the ones which we hope to look at phase 2 would include information-driven metrics as well as reinforcement learning-based methods, of which we shall get a glimpse in a little bit while. Finally, we hope to achieve a mission software framework which can cater to multiple vehicles and can be used for cooperative control maneuvers as a test bed, and then extend this further into the real world, where we can deploy these on the real vehicles and see that in action. So let me talk a little bit more about the current activities of the center. So as I said, we are building a fleet of vehicles. A few vehicles, 2 vehicles have already been built, and the third one is in production as of now. And you can see these 2 vehicles which have been built floating in our wave basin as shown in these 2 pictures. Just to give a sense of what's the process which goes through in building these models, it's quite a challenging aspect, and one has to think through many different things before the model is completely ready for deployment. It all starts off by making what is called as the plug of the model, and that is what you see in the first row of pictures. So we start from a blank slate, we set up some 3D printed parts, and we set up some frames of the ship, and then we loft timber woods across these frames to generate the geometry of the hull that we want to build. From this, we generate a inverse mold, which is called as the mold, and the first one is called as the plug. The inverse of the plug is called as the mold, and from which we infuse the fiberglass in order to get the final product, which is shown on the bottom right. After the hull is made, we have to make sure that the propulsion system is in place, the motors are chosen appropriately, the shafting arrangement is done properly, electronics are handled correctly before we can see the final vehicle in action. And once everything is ready, we are able to see the vehicle in action. And here we have a couple of videos demonstrating the test of that container ship, scaled container ship, which we have built in our wave basin. So the test that you are seeing here is called a turning circle test, where we apply a certain rudder angle and hold it fixed, so to allow the ship to turn at a constant rate in a calm water scenario. We have also been a little more ambitious in terms of taking this out to the real world a little bit, where we have taken it out to a lake within the campus, and we have performed different maneuvers here. So these 2 videos are demonstrating the bigger ship, which is the oil tankers scaled model, undergoing certain tests in the lake. The lake gives us a much more flexibility to look at different maneuvers, because we are not restricted in space, and we can try to do more cooperative maneuvers, put more vehicles together in order to achieve our control objective and to see how the vehicles perform to a given set of algorithms. Not only are we interested in building a fleet of vehicles, we are also interested in building the software stack of it. For example, we need to make sure that the guidance, control, and navigation stacks for these vehicles are appropriately built. And we do a lot of simulation studies as well in these areas. So we typically perform certain simulated studies, make sure our algorithms are doing what they are supposed to do, and then we deploy them onto our actual vehicles, which is what our next steps would be. So what you see here on this slide are pictures of a controller which have been designed using a deep reinforcement learning based architecture, where we have a vessel and we provide it with a waypoint, and the vessel tries to reach the waypoint using a controller that is driven by reinforcement learning. We also try to see, once the training phase is over, whether it can track a continuous set of control points in order to follow a path as is shown on the picture on the left. So you see that when we give a larger diameter circle, the path followed is more closer, but as we come closer to make the radius of curvature smaller and smaller, you do see some amounts of deviation from the path followed to the actual path undertaken. So this happens because the reinforcement learning is continuously not trying to particularly run on a, what you call a constant rudder angle, but it is adaptively trying to move. And it's not an easy task because we are not giving the entire circle at once, but rather specify the points one at a time. So when it is at this red dot, it's trying to achieve a control to reach this blue dot. And when it reaches this blue dot, and it tries to move forward to the next waypoint, which is why you see that it starts to deviate a little bit from the circular path. This is just one of the examples of the studies which we are doing. We are also looking at other traditional based control approaches and traditional guidance systems. And in the future, we hope to be able to bring all of these onto our test bed of vehicles and test them in action. So now that we have talked about why we need a center, what the goals of the center are, and how we are going to achieve them, I probably would like to spend a couple of minutes to discuss about how you can get involved in this center. And you can all get involved in the center depending on at which level you are. If you're a BTech student who is still pursuing a bachelor's degree, an internship might be of interest to you to come to our center and look and learn from us. If you are finished your BTech program, you might be interested in pursuing an MS, in which case you may apply for the MS program at the Ocean Engineering Department, and the center can provide certain funding for those scholars. If you are finished with your MS, you maybe apply for a PhD, and you can join our center as well. If you have finished your PhD, you may apply for postdoctoral positions, especially if you are a lot of publications already on track. You may even apply for young international faculty fellowships, which can be supported through our center. Similarly, we also support faculty visits from faculty from outside the country, where they can come and stay with us for a few years, a few months, and then collaborate with us on different problems in order to take these problem statements to fruition. So in all, thank you very much for your attention. Again, my name is Dr. Abhilash Somayajula, and one of my co-PIs is Dr. Suresh Rajendran. You can contact either of us with respect to any of your questions, and we can appropriately direct you to the other personnel within the collaborative group and put you in touch with the right persons. So that will be all for now. Thank you very much, and I will take any questions if there are.
Okay, so my name is Antonio from the University of Lisbon in Portugal. It's a pleasure to be here. This is a great program. So without further ado, I'll get into the questions that were posted. Some of them sound a bit cryptic to me, but hopefully they'll get clearer as we get into the discussion. So the first one by Kertana, and I read, but carrying container counts is more than traditional design, 3 interrogation points. Another way of thinking containers, maybe the question has to do with the fact that perhaps there is another way of transporting goods without resorting to the classical containers. This is my interpretation. I don't know, Abhilash, please go ahead.
Possibly true. I agree with you that the question is a little cryptic, but yes, if we are looking at vessels which are not container ships, even in that case too, they definitely are manned, and they do have an accommodation deck and we can definitely look at carrying more capacity if we are going in the autonomous mode of operation. So definitely, whether it is a container ship or any other form of a ship, I think it holds true that for a certain size of a ship, if the cost of the technology that we need to put on the ship to make it autonomous breaks even with the cost benefits with respect to the additional cargo that we can carry, it definitely is a win-win situation there.
Okay, thank you. So the next question was posed by Shyam Srinivas Surisetti, and it goes as follows. As fully autonomous ships are not introduced yet, as they are not much beneficial, why do we focus on those? How can autonomous ships be more beneficial and economical?
Yes, and I think that it comes back to the same point. Not all ships may possibly be beneficial if we made them autonomous. It really comes down to the economics of it. You have to look at it with respect to what are the technologies that you need to put on the vessel to make it autonomous. At the same time, you have to look at what is the gain in the cargo that you're able to carry, what are the operational costs on the crew that you're able to reduce. And wherever these will balance out together, I believe that is where we will probably say that the autonomous segment is more beneficial. And my understanding here is that especially for large ships, very large container ships or very large bulk carriers, the operational cost associated with the crew is a drop in the bucket as compared to the operational costs of the vessel itself. And in such cases, it may not hold much importance. And if we kind of see the development going on, it's more geared towards the mid-sized vessels where this advantage can really be taken. Maybe Dr. Prasad, would you like to also throw any light on this?
Yeah, can you hear me?
Yes.
Yeah, I think, as you mentioned, the shapes and sizes of the vessels will change in the future because of these autonomous conditions. So we will develop some more optimal type of vessels, which will use less amount of energy. So that will change, and then also the way of we doing the shipping business will change. We're thinking about this freight feeder type of autonomous vessels. One large vessel comes and then smaller vessels come there and take the items and deliver into different ports. So the logistics chains, the shapes of the vessels, how we do the business, and all these things will change with the autonomous vessels. So I think then you adapt quite a lot of savings, especially the energy consumption in these vessels also. And when you remove humans, you remove the human supporting systems, the space for that, and so on. So the vessels somewhat get more simpler. So that way also you save quite a lot of money or the cost in this business. So there are various aspects. The way of doing the shipping industry will change. So all these things eventually adapt to be more energy efficient and more economical shipping industry in the future.
Thank you.
Thank you. The next question by Shaurya Shukla is sort of a long one. My question is, when everyone is talking about autonomous systems, an autonomous car has various sensors and still it can lead to a crash with hard brakes, whereas a ship has an anchor which can reduce its speed but cannot stop. And the magnetic compass, gyro compass, gets affected during a voyage. There are various errors in radar and machines can malfunction too. Why are we focusing on autonomous cargo carrying vessels and not on autonomous yachts like Tesla cars? I must confess I didn't quite understand the core of the question, but I'll leave it to you, Abhilash.
All right. Yeah, I think the way I would kind of approach this is yes, and ships have anchors, but anchors are not very useful, especially if you're looking at a deeper water scenario. So yes, the challenge for autonomous ships is a little bit more than the challenge for the autonomous car. And my thought process here would be, again, coming back to the idea, we are looking at the autonomous cargo carrying vessels, not with an intention or say pet peeve, but rather there's an economics which goes behind it. And only when the economics supports it, it is viable to go forward with it. And clearly the economics supports it for certain class of vessels, which is where the development is going to be focused more on. So it's not so much so as, I think the problems with the autonomous car also existed when they started out. And it is only after tremendous amount of experience, whether it be in the number of miles they have put on the road, that they are now able to solve these problems and overcome them and move forward. And the same applies to the autonomous ships as well. We will have to spend considerable amount of testing, developing algorithms, making sure they're working fine. And after sufficient testing only, we will be in a position to bring them to the reality. But if we are thinking of why we should try at all, I think the economics is the reason why we would be trying that.
Okay, thank you. I noticed that in the Q&A window, it seems that the most recent message come on top. It shouldn't be that way. So I apologize to those who have asked or written the question. Sometimes the order may be different. All right, so a question by Patan Bashir Khan. Sir, how is autonomous vessels help to reduce accidents and advantages / disadvantages compared to traditional?
Okay. I think it kind of comes back to the same point which we were discussing in the previous questions as well, that with autonomous vessels, when we are removing the human element from these vessels, we are reducing the human errors, which are what are the most significant factors today. If you look at any marine incidents, they contribute to almost 60% of the annual incidents can be attributed to human factors. And that's where the reason for autonomous vessels, or the motivation for pursuing autonomous vessels, really comes into the picture. Because we are not just looking at the operational cost, but you're also looking at potential cost savings with respect to avoiding those accidents as well. And I think this is a part which I forgot to mention in the previous question, but hopefully I will do that now.
Thank you. Next question by Arjun Maripandi. Sir, is it possible to build an autonomous machine which collects the plastics in the seas and oceans? Because most of the sea animals are affected by plastic and majority microplastic.
Definitely. And I think, if I'm not wrong, there have been a few designs which have been trying to collect plastic from the oceans, at least on a smaller scale level. And these robots have been in operation. Some have been in the Europe, I believe, especially in the Netherlands region. Would I be right, Dr. Antonio? Are you aware about any of these?
I can say that what I know in Europe, there are many, many initiatives, and there's even a call now that is due on October 21st on litter collection at sea and on shores using robotic systems. Yeah.
Okay.
Okay, a question by Vishal H. May I know present capability of AI in this situation?
Yes, so AI is currently quite popularly being used for, I guess, for path planning. There are a lot of studies which are looking at path planning problems being addressed by artificial intelligence. Also in the control area as well, as you saw on what I presented in the presentation, we have techniques to try to see where the AI can be applied for the control as well. But the challenge with the AI is what I would believe is that explainability is one big concern which many people have, which in a traditional sense of control, you could guarantee certain robustness with controllers. But with the AI, in order to guarantee that, you really need lots of data and to be able to really come back and say that it will work, to be able to specify certain probabilities of exceedance and things like that.
Okay, so in order not to lose the thread of thought, I'll jump ahead and another question by Vishal. So I'm assuming it has to do with AI. May I also know the simulation capability?
Okay. Yeah, the work which we have shown here, that one is based on a Python framework where this tool is completely developed in-house. So the development of the tool also is a part of the center's works, and we are not relying on external tools. Yeah. And for the machine learning capabilities, as of now, we are not developing any custom with machine learning solutions, but rather we are using the existing machine learning packages like TensorFlow or PyTorch to try these training processes and to do the deployment.
Okay. There's a question by Ria Desai. Would autonomous marine systems require satellite communication? And if yes, how would we establish the required satellite infrastructure?
Yes. If we are looking at an autonomous vessel operation, you definitely would require satellite communication, either with respect to localization with GPS, or in order to even transfer back your data to the shore control system, where a human can be in the loop. Both of these would require, definitely would require satellite communication. Maybe I can ask either Dr. Antonio or Dr. Sanjay maybe to shed some more light on this area.
Not me, I'm not an expert on communications and satellites. So.
Dr. Sanjay, do we have him? Probably not. Okay.
Okay.
All
right. So a question by Vallabh Deolgaonkar. How will autonomous marine vehicles be used in marine research and surveillance applications? I find this question extremely interesting because if the ships are out there, they should be viewed as ships of opportunity to carry possibly scientific experiments or to perform scientific experiments. Okay, please go ahead.
Okay, the question is, how will autonomous marine vehicles be useful in marine research?
Marine research and surveillance applications.
Okay, definitely there will be a lot of scope of application, whether if you look at it in the defense sector or in the research sector. And I think one of the main fields, if you look at it in the research sector, is the oceanography people who regularly employ marine robots out in the ocean to collect information from the ocean and to study it and to gain more experience on the field. And I think in the defense applications, definitely would be interested in reconnaissance purposes or for detection purposes, or to be able to get a range and the bearing measurements more accurately. Definitely autonomous marine vehicles will be the way to go, because you're putting much lesser risk by not exposing a human, and a much smaller form factor vehicles can be deployed in a swarm and can be used for these surveillance applications. I'm sure there's a lot happening in this area, but maybe Dr. Antonio, you can give a better viewpoint for having seen this in action with oceanographic people.
Yeah. What people tell me, and they give me a very simple, compelling example. Suppose you want to sample an area, let's say 100 by 100 kilometers, and use a common vessel equipped with sensors. You start here. By the time you get to the other corner, I don't know how many months have elapsed. So the complete picture of the state is distorted. You lose the spatial and temporal scale. So the only way out of this is to operate a fleet of these vessels in simultaneously. So
in order to make that happen. Okay, yes.
yeah.
Maybe
So,
we can also ask Dr. Mike Benjamin. Do you also like to throw some light on this?
yes, of course, yeah.
Sure. Could you clarify the question again, if you don't mind, please?
Yes, I think.
The question had to do with the possible use of autonomous marine vehicles in marine research and surveillance applications.
Well, that is, I'd say that's one of the primary reasons why we have been exploring autonomy for marine vehicles. Certainly, transportation, unmanned or lightly manned cargo vessels, and larger ships are part of our motivation, but probably a more immediate and compelling motivation for developing autonomy, especially swarm autonomy, is to be able to enable large-scale ocean monitoring and sensing systems with smaller platforms.
Yeah, thank you.
Sure, I hope that answered it.
Sorry, are you done, Michael? Do you want to
I think so, yeah, I hope that answered the question.
Okay, yeah. So a question by Ria Desai. How would this deal with high tides and rough waters?
How would we deal with rough?
I mean, the autonomous vessels, how will they deal with high tides and rough waters?
Rough waters, yes, definitely. If you're looking at the scaled models, the reason why we are building these scaled models is to be also able to put them into our wave basin in order to generate the waves and look at how the interaction between them happens. And one of the biggest things when we are talking about tides and waves, which comes to my mind, is there is a big drive currently in order to reduce the powering of the ships so that the emissions can be reduced, so that we can go for greener ships. And as a part of that, we are trying to reduce the power on the ships, but the cause for concern is whether they can maneuver safely within the lower power limits or not. And that's a vast area of research which is happening significantly in the hydrodynamic area. So yes, definitely when we are looking at autonomous vessels, a lot of consideration does go into what is the environment in which they're operating and whether they can successfully operate in that environment or not. I know that when we are looking at gliders, for example, they are a little more, I've seen this more with my experience from Texas A&M, maybe somebody can correct me here, but I've seen that they think that the path they plan and what the final path that the vehicle actually exhibits are completely two different things depending on what happens. Especially in the Gulf of Mexico, when we usually have eddy currents come up, it can throw the vehicles off completely and definitely needs to be taken into account. But if you're looking at really very large vessels and operating in the deep sea conditions, I would presume that the tides would not be as important as they would be in the inland waterways. In the inland waterways, the tides would have more importance, but the waves would be considerably important out in the deep ocean. And that's definitely a thing of interest for this center, as well as for, I think, in general in hydrodynamic area.
Yeah. So I have a question by Kratik Agraval. What mechanism will be followed if there are any accidents or unfortunate things happen? Can AI fully replace humans? Do we need to introduce these technologies in the Indian Navy as well?
Yes. All right. Definitely for the Indian Navy part, I'm going to call upon Dr. Vijay Kumar to give his thoughts on this process for having been serving in the Indian Navy for a few years. But I think I can take the first part, that in case of an accident, definitely who is liable for the accident and who is to be blamed is a big question mark, which is still not answered appropriately, especially when operating in the international waters. So that's a framework which definitely needs to be built before we can see operation in the international waters. Over to you, Dr. Vijay Kumar.
So we will not, am I audible?
Yes.
Yeah. We will not look into Indian Navy in particular. Any Navy in the world would like to go for autonomous vessels. To have a secured shores, they would like to go for autonomous vessels which will be able to be there for 24/7 and able to monitor it. So all navies will be like to go for autonomous vessels.
Good.
Okay, there we go.
Sort of a more personal question. So I'm not going to read the full name. The initials are DV. And I hope DV, that you contact whoever, one of the, Professor Abhilash Sumaila. So, excellent webinars. I want to do MS. However, I'm lacking the confidence. I did my engineering in 2020, and since last 10 months working in one of international BPOs as a customer care executive, and I feel I'm missing my technical knowledge. So am I still eligible for this huge responsibility? Kindly assist us.
Definitely. I think if you have finished your BTech, you are in a good position to apply for the master's program. Definitely you can look at the different departments. I do not know which department exactly you are in, or which would be of area of interest, but you can definitely look up with IIT Madras, and if autonomous areas is of interest, please do get in touch and we can definitely talk more.
Yeah, you should do it. Okay, the next question by Ankush Singh. Please tell about the difference between AUV and ROV. So Michael will probably
yes.
want to expand on this. I don't know.
Dr. Benjamin, you want to expand on that?
Sure, the difference between AUV and ROV?
Yes.
Well, ROV sort of implies that there's a connection to a human constantly, whether it be a tether or virtual connection. And AUV, autonomous underwater vehicle, implies that the vehicle, at least periodically, is making its own decisions about what to do next. There's some overlap between the two categories. There is some work and research to provide autonomy for ROVs, even though you do have a human attached to an ROV. Sometimes ROV missions can be quite long and tedious for the operator. So there is a place for autonomy, even when there is a human at the other end of a tether, just to take the mundane joystick work out of the responsibility of the human. But in general, autonomous underwater vehicles are periodically, if not almost by default, always making autonomous decisions, deciding where to go next, etc. And ROVs have a human at the other end of a tether or a virtual comms link.
Thank you. There's a very short statement by Durai N. Cyber security is needed in marine stops. I think this is a very interesting issue. What about cyber security?
Yes, definitely. I think cybersecurity is a major concern when we are looking at the deployment of autonomous vehicles, especially with respect to spoofing, hacking. How do you prevent that from hacking, or how do you prevent that from spoofing? I think with respect to spoofing, you're looking at, I think the traditional strategy is to look at different types of sensors to measure the same thing, and then try to come up with the idea that whether am I being spoofed on multiple disciplines. Usually that would not be possible. So that's a good way or a good strategy, I would believe, but easier said than done. I guess it requires a lot of, it's a kind of now a cross between a computer science and the robotics domain. Probably, maybe Dr. Prasad, would you like to throw some light on this?
Yeah, I think one direction could be, I mean, this technology being developed for the other transportation systems also. So we can definitely adopt quite a lot of technologies already there and working on that. So yeah, I mean, other than that, we're thinking about building localized networks, localized positioning systems, and having multiple positioning systems to support vessels if in a situation if another systems goes down or it's been hacked. So there will be additional systems to be there to improve the reliability of autonomous navigation in the future, especially near the coastal area. We probably develop localized ground supported networks to support these autonomous vessels in a more highly accurate positioning systems. So that is really required when we're in the harbor area or in confined waters, more traffic lanes, and so on. So there will be multiple systems to be there to support these vessels in the future.
Thank you.
Personally, one of the questions that I don't know what the answer is, what about more mundane things like, a bunch of people coming and attacking the ship and taking over physically? Okay, that's another issue. Okay. Is there MD Afzal? Is there any possibility of using renewable energy to run these vessels if we make them autonomous?
Okay. If we make them autonomous, I guess the answer is partly yes. We do see deep, especially in the oceanography environment, you do see a lot of robots which are equipped with solar and wind powered robots which are coming up now for collecting data from different geographical seas. And they embark on very long missions where they can be supported by these renewable energies. But I guess if we are looking at the autonomous ships, we may be looking at a hybrid is what I would believe would be most advantageous. It cannot probably run completely on renewable energy, but definitely probably we can see some sort of a mix of renewable as well as the traditional propulsion systems.
Yeah, there are further questions along these lines. I'll get back to them. I'm not sure of how much time I have. I can be here forever, don't worry. So
maybe only concern is that maybe Ms. Richu, you have to let us know when we have to stop if the next one is coming on.
No, you can take on some more time. We don't have a hard stop. Please feel free.
All right. Okay.
There's another very interesting comment by MD Afzal. Amazing seminar. I'm interested to do MS, eligibility and where to apply. I have done BTech in 2020. I guess we already answered this one, right?
Yes.
Okay. So from Akhilesh Deshmukh, what are the legal procedures and conditions required to authorize the autonomous ships along with the ethical uncertainties?
Okay, legal procedures and conditions. Okay, I think the legal frameworks have to be set in place by International Maritime Organization. Maybe Suresh, would you like to take the question?
I'm also not very clear about that.
No,
I mean, we
they
know
do
that
not
there
exist as of now, definitely.
Okay. I mean, there are no rules also for existing for the autonomous vehicle because something has been so far materialized. But we have this IMO, like International Maritime Organization, and the COLREG collision regulations. So these are the associations or the organizations that comes up with the rules. So like when we are talking about the this renewable energy, so now that's another area of research, like a hot topic, where wind assisted propulsion. So just like our previous previous centuries, we have these sailboats. So similarly, along with the traditional propulsion, we also have this, we are also coming up with these wind assisted ones so that it adds more energy. Then there are a lot of research going on how to modify the existing propulsion systems. So these are like many researchers which is trying to make the ship more energy efficient, less polluting, and other things. And there are a lot of uncertainty also regarding the sea state, because if it is a sunny, mild, calm weather, everything is fine. Even anybody can ride it. But if it is a little bit harsh, cloudy, then everything goes wrong. And even if you miss the localization, we have the GPS, but even if we lose the connection for a few minutes, we don't know where it is going to be, because it's been drifted to somewhere else, and we have invested millions of money on that. So all these are the challenges we have, and I mean, learn step by step, and we are going forward that. So so far there is not, as far as I understand, there is no legal framework so far, typical for the EV, but there are plenty of for our traditional shipping. Maybe Prasad can also put some light on that.
Yeah, I think there are no legal frameworks, but some classification societies working on to develop some. The way what they're trying to do is they try to establish some sort of quantification methods. What is meant by a safety? For example, if you develop a navigation algorithm, you can test it in a simulated or bridge simulator type of environment, and you can navigate these vessels for a large amount of nautical miles, and then you can detect how many accidents can happen. So that way you can quantify this many nautical miles, this many accidents can happen. Is this a safe, or do we need some sort of a regulatory modifications? So this level of experiments are ongoing, but not a fixed legal framework yet.
Okay. There's a question by Umesh Chandra Surepalli. Can the research on autonomous ships help increase the efficiency in propulsion?
Yes, I definitely believe that would be one way to go about it. Because if we don't have the crew, and we can actually change the architecture of how the hull form over the waterline looks like, specifically to make it more streamlined such that you can reduce your wind drag forces, so as to get you a little bit more benefit in your energy consumption. That is definitely on the hooks, and I think Rolls-Royce has been a big proponent of this, at least in a few years back. I remember that they were particularly keen on this aspect in a few webinars that I attended with them.
Okay. There's a question, I couldn't quite figure out the essence of it, but hopefully you'll be able to, by Ginita Elisa Augustine. My question regarding is that offshore and onshore signal connections are different. And how can we get the signals without break for the autonomous systems in onshore?
I am not quite sure I have followed that as well.
Yeah, we already talked a little bit about communications in
communication, but I didn't quite follow what exactly they mean by without break in onshore.
I think by merging the two offshore and onshore networks. But okay.
Maybe not. I don't think I can answer that. Would anybody else on the panel would like to try? I'm not sure I understood that correctly.
Me neither. The person can always elaborate and come up with a different question.
Okay, all right.
So now this is a disruptive question by Samuel, Santosh, Kumar, Anna, and the name is not finished. Can we use it to understand how whales swim in the ocean?
Can we use it to understand how whales swim in the ocean? All right. I don't know whether autonomous ships are required to track down whales, but I do know that the Monterey Bay, in the Monterey Bay Aquarium, they do a lot of work on tracking down the whales which come from the Alaska region all the way to Baja, Mexico, and they spend a considerable amount of robotic ROVs or even AUVs to track down the whales, especially after they have reached to their destination. but I doubt that they are looking at tracking them on the way. I guess that has not been done. That's only for whale watching fun tours, probably, that as much as I know, as much as my knowledge tells me.
Maybe the question should be turned around. Can we learn from whales and come up with revolutionary ways of building these big vessels so that we learn from nature? But maybe, I don't know.
Yeah, in a biomimetic sense, yes, maybe.
Okay.
Maybe I can add a little bit comment on that. We
Sure.
have a project going on, CTEC, EU H2020 project. There's something called hydrofoil system fixed into the wave bow and creating energy from a wave field. So that was the project we're interested in. So this is kind of lessons we learned from whales, how they utilize wave fields to create renewable energy and then support the thrust into the ship navigation. So that's a kind of big project if anyone's interested.
Okay. There's a question by Sivayazi Kapagantula. How about developing the autonomous robots which can work on surface and underwater? As dynamic waves in the environment have more uncertain circumstances, how to deal with path planning with reinforcement learning? It's a bit muddled, I must confess. But I remember some time ago, there are some people advocating the use of submarines to replace, big transport ships. Okay, please go ahead.
For the first part of the question, I think I'll ask upon Suresh to give some thoughts, because he recently has asked me to be a part of one such project, which is an amphibious craft. So maybe he can take that question. I'll try to see if I can take the second part.
Yeah, I think the question which can work on surface, I think free surface, and on the ocean surface and underwater, that's what the question is about.
Yes.
So it's kind of a submarine, and then it comes on top. But yeah, so the one we have been proposing is something like coming inside from the water, deep down, and then flying to the air. That is also, some people have developed it, some people have tested it. So the partners in other countries, they have tested it. We can always come up with develop robots for that. Maybe there is nothing impossible. Yeah, Abhilash,
okay.
please.
And as dynamic waves in environment have more uncertain circumstances, how to deal with path planning with reinforcement learning?
Yeah.
Dr. Prasad, can I ask you to give a comment on that?
Yeah, I think the ship controllability is it can be a problem because it's not, vessels are not navigating in not like cars. They are navigating in roads. Controllability is pretty fixed, and we know how to do that. But vessels always, we have these under-actuation features in these vessels. So yeah, the controllability can be problems in high wave and wind conditions. It's a problem for humans too.
What about the path planning part?
Yeah, it's pretty much you deviate from the path planning and you have this quite a lot of external effects. So then we probably need additional strategies how to overcome that, especially avoiding collisions. So that means like detecting collisions earlier. And if you cannot control the vessels the way in a path planning algorithm, you need another strategy. How do you converge back into the path planning, or you deviate from a path planning and figure it out another path to do a more safer navigation? So these issues will be there in shipping.
Another interesting issue that came to mind is that I'm aware of at least one ship, I don't know if more than one. They are oceanographic ships that in order to hold still in the presence of rough seas, they flip into the vertical. And that's a big issue because they have to deal, with toilets and everything and the kitchen. Now, if we make them autonomous, then we don't have to worry about this anymore. So it's a wild thought. A desperate question from Jitesh Mohite. How do I get an internship Well, you have to get in touch with people, right?
Yes, please get in touch.
Okay. The next question, I think we have already touched upon that by Krishna Velu R. Thank you for a very interesting webinar, sir. Question, does the currently available technologies capable of making an autonomous vessel from unexpected environmental circumstances, accidents, and cyber threats during the marine navigation?
I think we have already covered this
I
question.
think we have already covered this, okay? So another question by T. Lakshmi Bai, please suggest any research topics on this. We could be here forever, right?
No, the research topics on, I think we are not very clear exactly on what, on the area of
general
of autonomous vessels. Oh, I think, as you rightly said, we will be here then.
Okay.
They can contact us always.
Yeah,
those who
you
are
can
interested,
contact us and we can,
because
we
yeah,
can
and
definitely
then
get
we
in
can
touch.
spend some time, and that will be better.
So I'm going through the list of questions again to see if we missed anything. Kratik Agrawal, why commercial ships are not nuclear powered?
Why commercial ships are not nuclear powered?
Yeah.
Okay, I think that has more to do with the fact that the dangers with having a nuclear propulsion is far more outweighs than the benefits you get out of it. That is my take on it. But maybe Dr. Vijay Kumar, does the naval?
I don't think so. It is economically viable also.
It's not economically viable.
Also, and it's not economically viable, and the danger which it poses is quite high and
far too risky.
Hard to risky.
Okay. The question by Amol Yerme, sir, what will be the effect on an ecosystem if this technology is used by every small as well as big autonomous vessel?
Can you repeat the question, Dr. Antonio?
What will be the effect on an ecosystem if this technology is used by every small as well as big autonomous vessel?
Effect on ecosystem.
I think Michael will be able to answer that, because especially if we think of vessels that carry acoustic equipment, for example, like multi-beams and stuff like that.
Okay.
Yeah, I think certainly vessels that are putting acoustic energy in the water is a concern. And there's always a lengthy permitting process for that here to do that. I'm not sure if that's what the root of the question was.
I think so. Thank you.
Yeah.
Faiz Akram, thank you for amazing webinar. My question is, whoa, this is a challenge. When you and your team are planning to design underwater vehicles?
I think for now we are going to be focused more on the surface vehicles to begin with, at least for a few years. But maybe then we will also be looking for cooperative underwater vehicles coming together with surface vehicles or interacting cooperatively with surface vehicles. But that may be down the line a few years, or at least 1 or 2 years at least.
Okay, I think I have basically gone through all the questions. The problem is that so there's a topic, wow, by a student of mine, Marcelo, on the previous topic of using submarines instead of cargo ships. Wouldn't that be problematic? We do not have satellite communication underwater unless we have a companion surface vehicle, but that would kill the whole purpose.
And I think it will also be more expensive to transport it underwater is much more challenging than transporting anything on the surface. The reason why we will prefer surfaces is you can carry, the buoyancy actually helps you carry a lot of the weight. But if you're trying to take everything underwater, then a little extra weight and then you're already sinking. So it's a much more challenging issue to carry things on a submarine, especially on submarines. One has to be very concerned with the amount of weight that we are putting on the vessel. I guess they are not very suited for carrying cargo. Ships have, on the other hand, the buoyancy working for them. So it makes much more sense to carry cargo in ships compared to submarines.
The next question, I think we have already alluded to this by Peter Bashir Khan. Any possibilities change in usage of fuel / solar / coal and the environment impacts using autonomous vessels? I believe we have addressed these questions.
Yes.
All right. I don't see any other questions. I apologize in advance if for some chance I missed one of the questions, but by all means, you can or contact the organizers. Thank you for your participation. Thank you very much.
Thank you, Dr. Antonio, for taking time out and
sure, a pleasure.
Moderating this session for us. And also thank you, Dr. Prasad and Dr. Mike Benjamin, for taking time out. I know it's very early out there in US when we started off here. So thank you for joining in.
Sure. My pleasure.
Yeah, thanks for the invitation also.
Thank you. Thank you. Thanks to everybody on the panel. You've spent so much time answering so many questions from the audience.
Yeah.
Thank you. We're very honored to, run this show with you and, for your extended participation. So thanks a lot. Thank you, Professor Antonio. Thank you, Professor Michael. Thank you, Professor Abhilash. Thank you, Professor Rajendran. And thank you. Thank you. Thanks a lot. Thanks, everyone. And thank you to the audience. Bye.
Have a nice day now. Thank you.